A lot of times in life, annoying situations arise, like where we have a charging port and it's all full and you still want to charge your phone, but you just can't put it in. Other times, we have situations like when we're talking on the phone, your phone's running out of battery, you plug in your charger, you try to reach it in, it just isn't going in because the charger length is too short. To avoid those situations, we would want a charger that would allow us to transmit electricity over a long distance, and it would have to be wireless. Crucial to being able to do that is wireless power transmission. Onto wireless power transmission, I'll be giving a demonstration of my own system here. This is the sender side with the power source, and this is the receiver side without the power source. Once electricity gets transmitted from the sender to the receiver, it lights up this LED light bulb. Now, we'll turn on the power source, and as you can see, the LED light bulb receives electricity wirelessly. We can move it a bit farther, and the light grows a bit dimmer. And as we move it closer, the light gets stronger. The maximum transmission distance for the system is 92 centimeters. Crucial to wireless power transmission is the LC circuit. I'll be showing it with a mini version of a portion of our system. It is made up of the inductor and the capacitor. This is the inductor, this is the capacitor. The inductor is a bunch of paint-coated coiled wire together. The inductor is something we can make ourselves by coiling paint-coated wire, as you can see in the clip. Now back to LC circuits. Here we have it on both sides. It uses a switch of magnetic and electric fields to transmit power wirelessly. After explaining the LC circuits, we could go on to the sender portion. This is the mini version of the enlarged system that I've shown. The sender portion is made up of three parts: the LC circuit with this, the NE55P, and the MOSFET gate. The NE55P, which is this little black brick, works in unison with the MOSFET gate to allow the LC circuit to draw in power at high frequencies, resulting in a high frequency changing magnetic field. Next, we have the receiving portion of our circuit. This is also the mini version of the enlarged thing I showed before. The mini version has a LC circuit, a 4-diode bridge rectifier, a capacitor, and the LED, which is the main parts. The LC circuit receives the power, which is AC current. It goes through a 4-diode bridge rectifier, which is this thing, and it turns it into DC current, which charges the capacitor. Then it can provide a stable current to the LED. After the explanations, we could go on to a distance vs power wireless power transfer chart that I summarized using my own data that I collected. For the x-axis, we have distance in centimeters, and for the y-axis, we have power in watts. As you can see, with distance, power decreases drastically. Now that we are done going over the generals, for the more specifics, you can reference this image shown. If you want to see longer distance transmissions using newer technologies, please follow the channel and hit the subscribe button. Thank you for listening.